Oh, okay, there we go. I like that screen. Either this one, or we can see the output a little bit better here. All right, let's do this one. So the last few days I've been working on some basic computational geometry and applying it to making procedural art. So I wanted to go through some very simple things with you. I have this program here, and I'm going to replicate this. Maybe, I don't know. Let me think about it a second. Let me see how this goes. Oh, look here. Right on cue. My friend Reggie's calling. As always through a live feed. It's almost expected when there's a live feed. He'll be calling. Let me move my phone because I'm sure that signal's probably cutting in through the mic. So this particle system here is making a circle. It's taking dots and it's moving those dots around in a circle to describe the shape, the circular shape. And then you can do stuff with those points. You can draw lines from the point to something else, to other points, or you can just make a line on that point and then rotate the line around. Maybe have a couple of these systems overlapping so that you can see the change or the difference in the interval. So that's the first thing I wanted to talk about is intervals. So if you start counting to 100 and you count one number every second, and I start counting to 100 and we both start on the same number at the same time, then by the time we get to 100, we're both going to get to the finish line at the same time. So our interval is equal. If you start on 0 and then I wait a couple seconds and then I start on 0, then like row, row, row your boat, our intervals aren't equal. They're kind of offset a little bit. And if you time it just right, you can get the offsets to, just like row your boat, form some harmony where they're in modulation. So that's kind of what I'm going to be doing with this art. I'm rotating one system set on top of another system set at different speeds. And where they overlap, sometimes you're going to get modulations, which is going to show some really cool geometry. Sometimes you're going to get like some chaos where it just looks like a mess. Other times everything is going to cancel one another out and you're not going to see much of anything. So getting these changes in intervals is going to give us lots of interesting geometry. So we're just going to start with this basic output here, and I'm not going to reinvent the wheel here. I'm just going to leave this code the way it is and just play with it live and let you guys see what happens when we do certain things. If you want to know how to make this particle system, let me know, and I might do this in a later demo video or tutorial video. But for now, this has got pretty much everything in it that I need to start making some really cool art and walk you guys through how I do the process for that. All right, where am I going to start at here? Let's look at this set very simply. Right now there's lines where the points are. Let's take these lines off. I'm just going to comment out what I don't want to use and then just comment back in what I am going to use. So I took the lines out and I'm just using points now. And we can see the points go around to make a circle, and then I have a scaling factor here. The size is going to increase over time to make the circle bigger. Now there's some interesting things that happen that you might want to know about in advance. If you do know about this, then congratulations, you've worked it out. But this is something I'm just kind of discovering for the first time. I mean, I know there's a difference between degrees and radians, but how that's expressed inside the procedures of coding and how things play out is kind of new to me, so I just have to experiment. So here I'm going to change the angle degrees. I think by default it's on radians, so factors of pi. I'm going to change it to degrees, so now we're working between 0 and 360. If I play this now, we're going to get a little bit of a different output. Well, actually a lot of a different output. The size it's not factoring the same way, so I'm going to have to increase that so that I can get it to go up in size and down in size a little bit faster. So I'm going to reduce that by a factor of 10. Let's be sure to multiply that coefficient. There we go. Now I can't see that stroke very well, so let's take that up a little bit thicker so we can see what's happening with these dots. Can you guys see that a little bit better? Okay, so when we use radians, the output is going to be a lot different than when we use degrees. So this is degree output, and the number of dots that I have in my system, it's 120, so that's like a third of a circle. So let's take it down, let's just go the full 360 dots, 360 degrees. We should get a complete circle, and we're making two of them that are the reflection of the other. So I'm actually making one, and then I'm just reflecting it to the other side to make a whole. So let's take this down by half. So now we have a semicircle, and since there's two, a reflection of a semicircle creates a whole circle. Let's take this down to a quarter circle. And we can go down to an eighth. So that's changing it to degrees. I'm going to take it back to, now we're back in radians, but I'm still dealing with 360 degrees in radians, and that doesn't quite work out, the math, because a full pi is like 3.1, whatever. So if I'm dealing in 360 degree, I'm dealing in like a huge magnitude of pi. So pi is happening many times when I cycle through 360 points. So what I can do is just back it out a little bit, take my size, multiply that times a fraction, and that's going to slow things down a little bit now. I've got rotations going on here. If you look carefully, I need to take up the stroke weight so you guys can see that a little bit better. So right here where it's 100 in that stroke, I'm going to change the alpha to 250. It's full intensity. We should be able to see that output a little bit better. Now if you look carefully, you can see they're their intervals are lining up and then not lining up. This is what I'm talking about. I can increase the size of the stroke so you guys can see a little bit better. Here we go. Now you see the circles there's one set of circles that's moving around and another set of these dots that are moving around in a circular pattern, and where they overlap, their intervals are equal or they're in modulation. And when they're offset from one another, they're out of that. So if we draw lines, start drawing lines between things, we're going to get to see the aliasing from when lines overlap and the angles that are produced that open up and decrease and vanish and reflect. So that's what we're going to do with this art. So I want to take, I think I'm good here at 45. We're going to be drawing a lot of lines. So let me take this point out here. I have an extra rotation in here. I'm going to take that out for now. I'm going to take that point out, and let's just draw our first sort of line. Okay, so we're drawing the line from wherever a dot is on that circular path. So the dot number 1, dot number 2, wherever it's at, we're going to draw a line from that dot to the width of the screen times a certain length, which is actually going to be a coefficient. So it's going to be a percentage of its width and a percentage of its length. So if we were at the very center of the screen and we drew a line that went to the width and went to the height, that line would go down in a diagonal. But we're rotating our canvas around the origin, that's the center point. So now the location for the lower right hand corner isn't going to be aligned with the width and height measure, because it's rotating around like the arms of a clock. So now we can exploit that to create all of this different aliasing. So here we can see the points are being drawn, and they're really thick, so let's make them thinner so we can see what's happening a little bit better. So up here at the top of that function I have a stroke weight, set that down to 2, and we'll just watch this output for a second. While I get a drink of delicious Ashland municipal tap water. You can kind of see, really, they're called illusory contours, where your brain sees shapes that are outlined in our brain, but they're not really outlined specifically there in what we're seeing. So you can see like an eyelid or an almond shape. It's not contoured for that, but our brain's picking it out, and we can see it moving around and around. And these geometries change, and there's some symmetry that our brain picks up on. So we're going to exploit all of that in this work here. So let's add more lines. Let's start reflecting more points. So let's see what this does. So now we just took the two sets that we have the lines coming off. We just reflected those coordinates. So wherever there were positives before, we have negatives now, and we can alternate. So if we have like a positive width and a negative height, we can produce another line that has a negative width and a positive height. So let's do that. And see what happens here. So now we have kind of like a kaleidoscopic reflection going on, where things are being reflected horizontally and vertically along into these 4 quadrants here. So let's just finish out that last quadrant, that last reflection. And there we have our kaleidoscopic systems. We have system 1 and system 2. It's actually the same particle system. I'm just drawing the lines twice, so it generates 2 different sets of particles that are using the same computational generation to move and to be located. Now there's where the intervals line up to create patterns, and then they disalign to create these interesting waves of patterns, especially in the center. Now we're going to do something really cool here in just a second. Let's take up the stroke weight a little bit, maybe up to 5. We're going to fade the alpha of that stroke, so it's not going to be as strong. We're going to take it down to 5. We're going to take that down to 5 as well, so each side's getting a weak alpha. Then up here we're going to fade the background very slowly. So we're taking away the output while it's being put down. And if you're not putting down a lot of output in terms of its intensity, then when we refresh the background, it's going to take out almost all of it. So if you put down more output and the background refreshes, it's not going to be able to take out all of it, and some of it's going to get left behind. And where it accumulates, that's where we get to see the output the most. So there's a gradient, there's this ghosting that happens, this fading, where the background has taken away most of the output and you can hardly see what's there. And then where there's a lot of output in one location that's being replicated many times per frame, when the background comes along, it's not able to take it all out, and then we see those geometries. So we start to see patterns that emerge that we may not have noticed before. So let me change some variables here so we can get a sense of what's going on along that. So I'm moving the output really quickly, and you can't really tell because one frame of that output is very faint. But if we keep overlapping this faint output on top of itself and changing it ever so slightly, then we're going to get to see this kind of like this lagged geometry that comes out of it, where things look more diffused and like they're fading off into a vapor. So color would be the next thing I'd want to mess with. We're going to use noise for that, and I have some offsets that are kind of nonsensical, but I'm going to use them anyway because I just want different colors that are kind of relational. Where is that at? Here and there. Oh, I guess I do have colors in there. It doesn't look like there are. What's going on with that? So this is controlling my noise, my Perlin noise offset. So the colors are a little bit more stark now. Just slow that offset and the values of noise will remain persistent longer, and then we get to see those color bands associated with that persistent value in the noise. So we have this now, and we can go up in the values. So we have 45 here. Let's draw more points off which there will be more lines, and that means that there's being more output generated in location with less background being taken away. Means we should be able to see more geometry. And just for variety, this stroke here, let's take it's a alpha up a little bit. So one has a low ghosty alpha and the other one has a high erasy alpha, I'll call it. In my mind, that's what I'm thinking, is that if the alpha is stronger, then it's going to take over or erase, depending on whether it's a positive or a negative value in what you're using. I don't mean positive like a positive number or a negative number. I mean in terms of space. So if you're drawing something black on a white background, then if you draw white overlapping it, then it's going to erase that output. So that's what I'm talking about in terms of positive and negative. Positive is output that we can visually see. Negative is output that's going to be kind of taking it away, erasing it to its background value. So that's some really interesting output. It's got there's these lobes here that we can see. Let's take the stroke weight down and see what happens. Let's just take it down to 1. And the size, let's slow it down by half a magnitude. And I want to increase the rotational speed a little bit. So let's just take this up to 2.5. And we can do something here too. We can rotate the second set after we translate there. And its rotations are, no, I've isolated and push and pop. So these rotations aren't cumulative. So if I am rotating this by 0.025, and then I rotate this by 0.01, there's going to be a lot of intervaling. There's an actual word for this thing that I'm talking about with intervals of geometries in rotation. It's actually called something. It's been used in art and design for a long time, and I'm embarrassed that I can't remember what the name of it is, but I've read it a few times and maybe I've heard people say it a few times, so it's not something that really sticks as a word. I more remember it as a concept of interval movements or interval, this interference or polarity of negative and positive space. So maybe I should remember the name of it. It'd be a lot easier to explain. So I like the wave pattern that we get coming out. You can see these concentric rings, these waves. And this circular geometry that arises from the linear geometry is really interesting. And there is a ton that you can do with this. Let's switch things around. Let's take this background color and make it black. Let's see what that does. It definitely changes the feel of it. it seems like I can sense more of the subtleties, the gradients and the colors a little bit better when it's black. And that's pretty awesome output right there. I'm really happy with that. This program, it started out as just a simple idea. I wanted to make a blobby, basically. But I got halfway through making the blobby, and I was testing out some things, and I thought that looked cool, and I was like, oh, well, let's just change that. And then that looked really cool, and before I knew it, an hour later, it was no longer blobby. It was more this computational geometry that you see here. This really amazing output. I am so happy with this. I'm going to keep this one. I like this output here. But this would make a background for a title, so you could have this raw output, put it in a like a video editor, put some text over the top of it, and you have something really compelling that's going on in the background that makes it interesting but doesn't really detract from the message that you're trying to communicate with the foreground. So if you like, I'll take a moment here and maybe if I change my windows, I'm going to scroll through this code and give you guys a chance if you want to copy it. Oh, one more thing before we go. I want to change this to back to degrees and run it and see what that looks like. And I think because now we're dealing in degrees, this doesn't have to be so big. So I can just take that out. That's kind of interesting. Very prismatic. And you can see this contour here. That's interesting. There's a lot of asymmetry. I think it's because of the different rotational angles. So let me take this rotation out here. That's throwing things off. I'd like to see how the symmetry of the system plays out. Isn't that interesting? How many particles am I using? 90? Let's use 360. Let's just crank it up here. This is going to click along. I think it'll be okay. That's just too slow. I can't take it. It's a little bit faster. It's just really weird how it's not lining up right. We'll speed up the rotation, see if that does anything interesting. Not so much. I do like it better on the radian mode than degrees. When I wrote this program, I wrote it in this idea of degrees, using this 360 degree index loop. Oh, I hear the jet going by. So now that, and it's I should have a quick line in here for factoring this to pi and just do the conversion myself. So let me change that to that. Oh, that's kind of cool. Anyway, before I change this too much, what was I doing? Oh, I was rolling through here so you could see the code. So just pause on the part that you need the code for. Now again, there's all kinds of stuff in here that doesn't really do anything. It was added for a purpose that no longer is being served. So just keep that in mind. Alright, I'm going to compile some of this output into a video, like a highlight reel, and I'll upload that in a day or two, but I think that's going to do it for this live feed. Alright, well, thanks for watching if you're checking this out later, and as always, until next time, take care.